Hello. You're about to begin an interesting and rewarding training experience on the 4700 Finance Communications System. This training is going to prepare you to handle most of the service calls on a 4700 system. If you have some experience working on banking products such as the 3600 system, you should be able to pre-test through a significant part of this course. On the other hand, if you have little or no prior experience servicing banking products, you'll find the course to be both informative and challenging. I'd like to emphasize that this FIS course will prepare you to service the 4700 system. Education Center training is not required. To take the course, you'll need the FIS2 terminal, these 5 4700 system reference documents, the student guide, these 2 video discs, and of course, a video disc player. If you are missing any of these items, see the FIS Education Coordinator in your branch office. It's especially important that you have the video discs because they contain information that is not available in any other course material. Before you begin working with these materials, let me tell you a bit more about the course and what to expect from it. The course has been broken down into 4 units of study. Each unit requires about 4 hours to complete. Each unit has been further divided into training sessions. Overall, there are 14 sessions in the course. The sessions have been grouped so that the first 8 will provide you with the skills to repair the 4701 controller, which is your primary job responsibility. Your second major responsibility is to be able to verify the customer's use of the 4700 subsystem problem determination procedures. We have devoted the second part of the course to teaching you that skill. Sessions are organized somewhat differently than most FIS2 courses you have previously taken. In most FIS2 sessions, you are given the pretest for all objectives, all of the learning activities, and finally, the session post-test. In this course, you will receive the pretest, learning activities, and the post-test for one objective at a time, as the following diagram shows. This is the framework of a complete session. Following the session introduction, you'll be given a single objective and allowed to take a pretest. If you pass the pretest, you'll skip the learning activities and go to the assignment summary and the next objective. If you do not pass the pretest or choose not to take it, you'll be given the learning activities. After completing the learning activities, you'll be administered a post-test item. If you successfully pass the post-test, you'll be given the assignment summary and the next objective. Then, the whole procedure is repeated. If you fail the post-test, you'll receive remedial and then have a second try at the post-test. After successful completion, the next objective is presented. The session framework you've seen works equally well for all types of subject matter. If a session deals with the development of a hands-on skill, such as using the console keyboard to invoke diagnostic tests, the learning activities are supplemented by audio-visual presentations and/or simulation sessions. In this course, audiovisuals and simulation are used extensively. For instance, video disc presentations are used to show you features and functions of the 4700 system, 4701 component locations, 4701 console indicators, controller startup procedures, maintenance procedures such as invoking tests from the console keyboard and using the diagnostic switches to loop the tests. The audio visuals used in this course graphically illustrate important procedures that you must be able to do. In some instances, we have followed up the video with simulation to give you a chance to practice the procedure much as you would do if you were sitting at an actual machine. The combination of these techniques and the skill and knowledge you possess as a CE will enable you to service the 4700 system successfully. Please return to the FIS terminal and continue with the course opening.
The IBM 4700 Finance Communication System provides a highly versatile line of hardware and software products created specifically for the needs of the finance industry.
With its advanced technology, the 4700 system offers new dimensions in terminal design, system function and performance, installability.
Terminals, in particular, are designed for the user's convenience and comfort. Displays can tilt and swivel for optimum viewing from many angles.
And the operator can adjust the screen image in several ways to account for different lighting conditions and viewing preferences.
Small, modular devices provide flexibility in designing the workstation that's right for you. Workstations that meet the needs of tellers, administrative platform personnel, and even customer self-service. With a powerful yet compact controller, the 4700 offers greatly enhanced system function and performance over the very successful IBM 3600 system. Controllers are designed to support multiple applications, such as teller, administrative, automated teller machine, and self-service. And 4700 programming support enhances your ability to implement and maintain the system. For example, COBOL, the most widely used language in the industry, is supported for the development of controller applications. The 4700 system continues IBM's impressive evolution of products for the finance industry by providing compatibility with 3600 systems. This means that 3600 users can easily migrate to 4700 devices to take advantage of the many extended and enhanced functions provided. Let's look at the 4700 system and its components in more detail.
The 4704 display terminal is a modular display and keyboard terminal that can be customized by the user to meet various application and workspace requirements. Flexibility in tailoring the workstation is provided by a variety of small, individual components. A compact cathode ray tube display with a 5.5-inch screen measured diagonally is designed primarily for the teller workstation and can display up to 480 characters. The 9-inch diagonal display can show either 480 large characters or 1,920 standard size characters, depending on the application program. This display is ideally suited for either administrative or teller workstations. In addition to the 4704's modularity, the display includes many features for the convenience and comfort of the operator. These include sharply defined characters in a 7:9 matrix, dual intensity for highlighting data, upper and lowercase characters, status information displayed at the bottom of the screen, brightness and contrast controls which can be adjusted by the operator for individual viewing preference. Anti-glare filters protect against light reflection and provide for either yellow characters on a brown background or bright green characters on a dark green background. Perhaps the most unique feature of the display is its ability to tilt and swivel to provide a variety of viewing angles. A foot or riser is a standard feature. With the optional cradle, greater flexibility in tilt angle can be obtained. And by hanging the cradle, as shown here, the display can also swivel from side to side while not occupying any counter space.
Associated with these displays is a choice of 3 compact keyboards. The function keyboard has 50 keys, 45 of which can be customized by the user. Blank labels and clear plastic caps are provided for labeling these keys. The alphanumeric keyboard provides 62 engraved keys in a typewriter-style layout. An expanded alphanumeric keyboard provides the typewriter-style layout plus 15 keys that can be customized and labeled by the user. The function and the alphanumeric keyboards can both be used at a single workstation to provide additional capability and flexibility. The keyboards also have a riser that can be inserted into the bottom to alter the slope of the device. The keys themselves are designed for the comfort of the operator and include anti-glare surfaces, keystrokes that can be heard and felt, and uniform spacing between keys. All keyboards have an audible alarm. Optional devices that can be included at the workstation include a magnetic stripe reader and a PIN keypad to enable a customer to enter a personal identification number. All the 4704 devices attach to a separate display control module, one for each workstation. This compact unit contains the power and control logic for the devices linked to it, enabling the actual workstation components to be small and use less counter space. The flexibility offered by the 4704 devices means that you can configure the workstation that is right for your particular requirements. For example, you can have this teller workstation, or this one, or an administrative workstation.
The small size of the 4710 receipt validation printer also provides flexibility in arranging the printer with the 4704 at the teller workstation, and the printer can be shared between two tellers. The 4710 printer is designed for the teller workstation. It prints on single or multi-part documents such as checks and receipts and can record transactions on a journal roll. Features include a clean hands ribbon replacement cartridge, a bidirectional matrix printer with speeds up to 120 characters per second, and bold or double width characters for emphasis. For passbook printing requirements such as in the thrift industry, the 3616 passbook document printer is fully supported in the 4700 system. The printer will also be available in the new neutral color of the 4700 line to enhance visual compatibility. A typical teller workstation in the thrift environment might look like this. The 3616 is being shared by the two tellers, each of whom uses a 4704 display terminal.
Managing the 4700 system is a powerful and compact controller. The 4701 is a tabletop unit that provides the capability to support multiple applications, teller, administrative, and automated teller machines, for example. Storage and loop capacities have been increased over previous 3600 controllers. For example, the 4701 has up to 512K bytes of storage, providing up to 436K of addressable storage for device attachment and user applications, and a total loop capacity of up to 16,800 bits per second, which is a 40% increase over the 3601. A single diskette drive is standard, providing approximately 560,000 bytes of storage. With an expansion module, a second drive can be added, providing a total of about 1 million bytes of storage. This is twice the capacity available on the 3605. The 4701's integrated operator panel is designed to enhance the user's ability to do problem determination, host link management, and system startup. These activities may also be invoked from a terminal authorized for this purpose. Programming support for the controller provides for compatible execution of 3600 assembler language programs. In addition, both 4700 devices and 3600 devices are supported.
A new capability, the Local Configuration Facility, LCF, can enable a user to create an operational system diskette on the 4701 controller itself, with minimum dependence on an IBM System 370 or 4300 processor. With this facility, the IBM processor is required only to assemble or compile the user's application programs. As we said earlier, host support for the 4700 system includes the ability to develop controller application programs in COBOL, the most widely used programming language in the finance industry.
The IBM 4700 Finance Communication System. a line of products designed for financial institutions,
New concepts in user-oriented terminals for tellers.
for customer service and administrative areas,
More capabilities in function and performance.
an important member of IBM's total system of products for the financial community.
During an earlier presentation introducing the 4700 system, you saw some typical arrangements of 4700 terminals in a bank lobby. Remember, this is how you saw a teller's station. And this is how you saw an administrator's station. Does the system know the difference between a teller or administrative station? Not really. Software architecture of the controller is designed so that work is performed by logical workstations. A logical workstation is defined as the association of an application program, a unique portion of the controller's storage, and one or more terminals. There may be from 1 to 60 logical workstations in the controller, depending upon installation requirements and available storage. A typical commercial bank may require a system like this: 4 teller stations located at the savings and checking account windows. 2 stations are also required in the loan department, and 2 are required in the administrative area. 8 workstations in all. Each workstation is connected to the 4701 controller and has its own work storage area. Each grouping of workstations is logically associated to a specific application program. Workstation 1, shown here, is reserved for an IBM supplied application program called the System Monitor. Using a terminal that's been dynamically reassigned to Workstation 1 from one of the other workstations, the system operator or the CE can use the facilities of the System Monitor to perform a variety of system control and maintenance tasks. You'll be learning a lot more about System Monitor functions as you go through the course. So far, we have defined the term logical workstation as a relationship of an application program, controller storage, and one or more terminals. Now let's see how the I/O terminals are set into various workstation configurations. Terminals assigned to a workstation may be private or shared. A private terminal is used by only one operator and it belongs to only one workstation. In this schematic, Workstation 2 and Workstation 3 are 2 typical examples of private terminals. A shared terminal is used by more than one operator. In this example of Workstation 4, a 4704 keyboard display is being shared by 2 operators, designated A and B. A shared terminal is also one that belongs to more than one workstation. In this example, the 4710 printer belongs to Workstation 5 and Workstation 6. Terminals that are usually shared have duplicate controls for the operators, as indicated here by the 2 start keys on this 4710 printer. Shared printer outputs contain program-controlled means of identification so that the output can be matched to the respective operator. Here, on the journal roll printout of the 4710, the letters A and B are used. In addition to private and shared terminals, most systems are configured so that some terminals are online but unassigned. These terminals are placed in what's called a free pool. Terminals from the free pool can be reassigned dynamically to any workstation as needed, even if the workstation is on another loop. For instance, if this 4710 in Workstation 2 was defective, this 4710 in the free pool could be assigned to perform the required task. This would allow Workstation 2 to continue to operate normally. Well, We've now discussed how various arrangements of private and shared terminals are viewed as workstations. What we really haven't determined is how many terminals make up a workstation. 4700's system architecture limits each workstation to 8 addressable components. Because some terminal types have more than one addressable component, the actual number of physical boxes assigned to a workstation varies depending upon the machine type being used. For instance, a 4710 document printer has one component whose address is 4. On the other hand, a 4704 keyboard display with the magnetic stripe encoder feature has 3 addressable components. The keyboard's component address is 1, the display is 2, and the magnetic stripe encoder is 3. Other finance system terminals have various features such as the 4704, resulting in multiple addressable components in a physical box. This results in most workstations having considerably less than 8 physical devices assigned to them, as in the example we've been using. Occasionally, it will be important for you to determine which I/O devices are assigned to a specific workstation. You could ask the bank tellers or other personnel. In many instances, they will provide you with the information you need. However, if they are inexperienced, they most likely will not be able to tell you what you want to know. What then? The next best way in which you can get this information is to consult a CP/Gen listing. This document, shown here, is created as a byproduct of the system generation. In addition to other data, it contains a complete listing of all the terminal workstation assignments. For example, in this CP/Gen listing, ST2, meaning Workstation 2, consists of a 4704 Model 11 display. From statements such as these, you'll be able to figure out all the workstation assignments on the system. Because the CP/Gen listing is such a useful document, you should ask your customer to provide copies of it at the host system and all remote sites. Later in the course, you'll learn more details of the CP/Gen listing and about how it is used during subsystem problem determination. And now that you know the CP/Gen listing contains some important answers for you, let's conclude this presentation with a listing of the terms and concepts that were discussed: logical workstation, private terminals, shared terminals, free pool, number of devices in a workstation, system monitor on workstation 1, always, CP/Gen listing. Please return to the FIS terminal to continue the course. This diagnostic diskette is probably the most important service aid you have to help keep the 4700 system operational. Because it is so important, we are going to provide you with 3 different presentations about it. In Part 1, this presentation, we're going to demonstrate a normal startup. In Part 2, we'll show you several examples of how effective the diagnostic tests are in detecting startup failures. In Part 3, we'll show you how to use the diagnostic switches to loop the various test routines. Before we see how a startup is actually performed, let's examine what a startup really is, an overview, if you will. During startup, first, a limited test of the controller hardware is performed by the power on tests. Then, extended controller and DCA tests are read in from the diskette and executed. Next, the controller is initialized by loading the control program and the system monitor program. After the 4701 is initialized, a series of controller adapter tests are loaded and executed. These include tests for the host adapter, loop adapter, and diskette adapter. Startup is complete when the 4701 display contains the AOK message, and the controller can be put into operational state by operating the diskette drive handle. The diagnostic diskette we'll be using during this demonstration contains the 4701 control program, and the system monitor program. These two programs are automatically loaded into the 4701 during the initialization phase of the startup. These programs are needed to run the controller adapter tests. The diskette also has the following offline tests: the extended controller tests, controller adapter tests, and the device routines. The configuration of the 4700 system we will use to demonstrate the startup consists of a 4701 controller, a 4704 keyboard display on loop 1 address 01, a 3604 keyboard display on loop 2 address 02, and a 4710 printer on loop 2 address 03. Now let's look closely at the startup procedure. Startup begins when you insert the diagnostic diskette in the controller and press the power on key. Now, the power on read-only storage or ROS tests begin. First, the console indicators are tested. Then a series of e-prefixed messages will appear in the 4701 display as the controller hardware is tested. During this 20-second test, the controller card, basic controller electronics, and all storage cards are tested. Incidentally, if an error is detected during the test, the controller is stopped, the check light goes on, and a 4-digit code will flash in the message display. If the power on tests run error-free, the extended controller tests are read in from the diskette. You can tell the tests are being read in by this sound coming from the diskette drive. These tests check out the controller more extensively. If the DCA feature is installed on the 4701, the DCA adapter test is executed next. The message display shows T100 when the test begins, and T199 when the test is completed. The controller can now be initialized. In the 2 minutes it takes for this operation, the control program and the system monitor program will be loaded. Remember, the 4701 needs these two programs to control the execution of the adapter tests, which are run as application programs. You can tell that the control program and the system monitor are being loaded when the I messages appear in the display. When the 4701 display contains the message I-699, the keyboard display attached to loop 1, address 1, will be readied. Indications are the word OK will appear on the bottom of the 4704 display, and an audible tone will be heard. Next, a 2-line message will appear on the 4704 display. The first line tells you basic information about the diagnostic diskette, such as when it was created. The second line has a 5-digit message, 00001. That message is a request to key in the type of start you want. If you ignore the startup message and don't enter a start code, in approximately 20 seconds, the system will default to a cold start. Code 8. Cold start resets the controller log records. After initialization is completed, this message is displayed. If you choose not to enter a 0 or a 1, the controller will take the default option, 0, and execute the following group of offline controller adapter tests. The host adapter test is first to be read in from the diskette. The messages T200 through T299 indicate this 15-second test of the high performance or the common communications adapter, depending on the host feature that's installed. From this point on, in the startup, you will be able to follow the progress of the tests on the terminal display and the 4701 message display. Now, we'll use a split screen format to show you both displays. Incidentally, the S after the T200 message tells you that the test has started, and the C tells you that the test has completed. The loop adapter test is next. It's the longest adapter test, running at least 25 seconds, and considerably longer if all 4 loops are installed. Messages T400 through T499 tell you the test is being run. The last adapter test checks the diskette adapter. Messages T600 through T699 identify it. When you have run all tests successfully, the controller display shows A-OK. Operate the diskette drive handle to cause an interrupt. In about 10 seconds, the controller will go into operational state and you'll see the message display containing a minus, quotation mark, plus, plus. These are the normal indications for this system. Because of differences in installed features, your customer's indications may not be the same. For example, if the DCA feature is not installed on the 4701, the low order position will also be a minus. Other indications that you're in an operational state are the 4704 displays a T998 message. This concludes our demonstration of a normal startup on the Diagnostic Diskette. Here, you saw the messages that are normally displayed when the power on tests and the extended and controller adapter tests are run. You also saw the controller initialization messages. Please return to the FIS terminal and continue with the course. Welcome back. This is the second of 3 demonstrations using the Diagnostic Diskette. In this part, you'll see how the internal power-on tests and the offline adapter tests are used to detect controller failures. This time, when we start up the 4701, we'll simulate a failure. To illustrate the overall effectiveness of the diagnostics, you'll be shown 3 examples: a logic card failure, an erroneously set switch, and an open loop circuit. First, I'll turn off machine power. Then, I'll pop loose the O1A S2 card to simulate a defective storage card. The power-on tests should detect this failure. I'll install the Diagnostic Diskette and initiate the startup by depressing the power-on key. The power-on tests are running. The 4701 has stopped with an E002 error. To determine if this is the correct stop, refer to the 4701 Repair Manual, Chapter 2, Offline Tests Symptom Index Chart, which refers you to the E-Messages Symptom Fix Charts. The message E002 tells us that the third 64K storage card is defective, and it should be replaced. This board layout chart from Chapter 5 shows that storage card 3 on a 4701 Model 1 is the S2 card that popped loose. For our next example, let's look at how the diagnostics can help to locate a defective or improperly set feature switch. You may recall, we said earlier, that the 4701 operator's console has two 8-position feature switches. The 4701 repair manual, figure 5-8, describes how to use the upper feature switches 6, 7, and 8 to indicate how many loop adapters are installed in the 4701. The controller we're using has 2 installed loops, so switch 7 should be on and 6 and 8 off. I'll change the switch settings to show only 1 loop adapter installed by turning off switch 7 and turning on 8. Let's see how the diagnostic reacts. I'll initiate a startup by depressing the power on key. Looks like the power on test ran okay because the sounds coming from the diskette drive indicate that the extended controller test is being read in. Oops, there's a failure. The error stop message is E028. The e-message symptom fix charts in the 4701 repair manual lists the cause as a mismatch between the feature switches and the installed loop adapters. The action column directs you to correct the switch settings or remove the extra loop adapter card. Here you see that the diagnostic tests can be very effective in detecting this type of failure. For our third and last example, I'm going to simulate an open loop circuit. I'll open loop 1 by removing a loop connector from the back of the 4701. The loop adapter test should detect a failure of this type. Keep in mind that I'm simulating what would happen if any of the loop circuits had a line break. That could cover a lot of territory. Pressing the power on key will initiate startup. We'll show you the important messages as each diagnostic test is run until the error is detected. The controller has stopped. The check light is on, and the message display is blinking. E412 is our error message. Referring to the symptom fix charts, message E4N2, the cause of failure is listed as a loop 1 circuit failure, which coincides with the failure I made happen. Now you've seen the fault detection and isolation capabilities that are built into the Diagnostic Diskette and the symptom fix charts. This concludes the second demonstration of the Diagnostic Diskette. During this video, you saw how to handle errors and how to use the 4701 documentation. Please return to the FIS terminal and continue with the course. This is the third of a three-part demonstration showing uses of the Diagnostic Diskette. In this demonstration of the Diagnostic Diskette, I'm going to show you the procedures for looping the power on tests and the extended controller tests, and finally, the loop adapter tests. The diagnostic switches are used only with the Diagnostic Diskette. The switches allow us to exercise the hardware, to show up intermittent failures, and to validate repairs. The 4701 Repair Manual, Figure 2-3, describes the procedures you are about to see. You'll find the diagnostic switches behind the 4701 console cover, just below the two groups of feature switches. To loop the power on tests, I'll set switch 4 on and turn on the power. The message display and the status indicators will light up every 20 seconds to let you know that the tests are actually looping. There, the test has looped. To terminate the test, flip off the switch and depress the reset key. To loop the power on tests and the extended controller tests, Figure 2-3 tells us to set switch 3. I'll set switch 3 and then depress the reset key to initiate a startup. We'll show the entire test being run, since it's a short one. The sounds you hear are coming from the diskette file. They tell you extended controller tests are being loaded. Again, when the message display and all other console indicators are lit, you know that the selected tests have been looped and that the power on tests are being run again. To terminate the test, flip off switch 3 and depress the reset key. For our final example, we'll look at the procedure for looping an offline adapter test. Here are the main steps in the procedure to run the loop adapter tests. First, we'll turn on switches 3 and 4, and then depress the reset key to initiate a startup. When you see M999 in the display, turn off switches 3 and 4. Then make your test selection. To run the loop adapter test, we'll turn on switch 2 and depress the interrupt key. The controller then loads the control program and system monitor program from the diskette. This takes about 2 minutes, so we won't show the elapsed time. When initialization is complete, the control program takes over operation of the 4701. Because switch 2 is on, the loop adapter tests are then executed. The T400 messages confirm this. To end the looping test, press the reset key. To restore the machine to normal operating conditions, don't forget to turn off all diagnostic switches. This concludes the demonstration of the Diagnostic Diskette. In this third part, you saw how the diagnostic switches on the 4701 operator's console could be used to select and loop diagnostic tests. Please return to the FIS terminal and continue with the course.